All right, guys, so let's introduce the concept of variables. Now, variables in Rust are very similar to other programming languages with a few slight differences. So, a variable is declared with the let keyword, okay? So let variable name equals the value. So for instance, we have here two examples, one a string and one a integer, okay? So let's try that out in our code. I'm gonna say let name equals whatever, Alex. And then we're going to define a variable, let's say age equals 32. Now you can see here that already we have the types filled out by our IDE. So the first one is an @str. This is a kind of a string variable, but in scalar type, okay? The string variable is normally a class, an object, but here we have, if we declare it like this, we simply have a scalar type str, which is simply a collection of characters. And the second one is the age. Here we have an I32, which stands for integer 32. Now we will discuss more about the types of variables that we can have in the next video. For now though, I just want to introduce the variables and talk a bit about that. So basically, Rust is a strongly typed language. So what does that mean? It means that at compile time, Rust knows exactly the type of variable that you declare, okay, whether or not you mention the type. The variable type is optional, so you can see here that we haven't declared any particular type for either one, and that is because it can be inferred. So by default, if you pass something between quotes, the system, Rust, will assign the variable type string here, okay? And here we have an integer. But also we can specify the type explicitly. And I want to give you an example of when we actually need to specify the type explicitly, otherwise we might get an error. So for example, we have our let amount variable, and here we define the type by placing a colon here with an I64. The I64 simply means an integer of 64 bits, okay? And we define a large value for that integer. Now the problem is, if we don't define the type and we pass a large value, since this is by default an integer, this will cause an error. Okay, so let's go ahead in our code. First, let me just try to run this. Okay, so we have our variables. We don't actually print them anywhere. By the way, here we are getting a bunch of warnings. So these warnings will simply tell us that the variable name is unused, okay? And the same thing for the variable age. It's simply unused. It doesn't really matter anything. The warning is just there to let us know. If you want to get rid of those warnings, here at the top, simply say $allow inside square brackets, allowed, and inside parentheses we're going to say unused underscore variables. Okay, so that just informs lint that we are okay with unused variables. Okay, so if we run this again, we're not going to get the warnings. We will talk about lint in greater detail later on in our course. All right, so where were we? We are going to define a couple of variables and show you when we actually need the type, okay, explicitly. So let's say amount equals, and we're going to put a large number here. Okay, if we run this, we're going to get an error, literal out of range, because this is by default an I32 and this is larger than 32 bits. So in that case, we're going to define this as an I64. Okay, so we're doubling the size in memory. If we run this, it runs just fine. Okay, so sometimes it's very important, and sometimes you might want to do that just for having your program more explicit so that it's easier to read, let's say. All right, so what about variable names? Well, names, as in other languages, can contain letters, numbers, and underscores, and they need to start with a letter or an underscore. You cannot have a variable name that starts with a number. Now, Rust usually follows the snake case naming convention, which simply means you have lowercase words in case you have multiple words in the name of the variable, separated by underscores. So snake underscore case underscore whatever words you need to put after that. Okay, so the snake case convention. Now, here is an interesting thing about variables in Rust. They are immutable by default. So that means we cannot change them. Okay, so let's go back to our code. If I try to change one of these variables, let's say age, and I want to give it the value 43, okay, we already get an error from the compiler that says cannot assign twice to immutable variable. Okay, so we're not allowed to do this. However, we can declare the variable mutable, and we do that with the mut, the mute keyword. Okay, so if we go here, I declare my age variable mutable, and I run this, that is perfectly fine. Now, I am getting a warning here that says value assigned to age is never read. Okay, and that's just the compiler telling me that this age variable that is reassigned, nothing happens to it. It's not used. So that might raise some flags when you're developing code. If you don't want these kind of warnings, we have another element here that we can put at the top. Let me just copy that correctly. Okay, so copy that, and I'm going to put it here at the top. And here we have warn unused assignments. Okay, so running this code again, there is a warning. All right, so instead of warn, we need to put allow here. So we're allowing unused assignments. So if we do that, then we get a correct build. Now, if I try to print line the variable here, so I'm going to print line, that's too many brackets, print line the age variable, okay, that's going to give me 43. And of course, if I do that before the new assignment, that's going to give us 32 and then 43. Okay, so that's how it works. Now, importantly here, shadowing is allowed in Rust. So we can declare the same variable name twice, okay, and we reassign that variable name. So let's try that out for ourselves. I'm going to say let color equals blue with double quotes. Okay, and then I'm going to reassign that color equals, let's say, 86. Okay, so I'm reassigning it even to a different type, and that is perfectly fine. Let me just print it out. And I'm going to print color here. I'm going to run the code, and then we get 86, right? So we are allowed to shadow variables. That means to reassign them if we need to. And then finally, we are allowed to declare multiple variables simultaneously. Okay, so we can bunch multiple values together to assign them at the same time. And that is actually very useful later on in our course when we, let's say, get results from some function or some, some process that gives us some information. We assign all those values to various variables. So let's try that here. We're going to assign A, B, and C, and that is going to be 43, 86, and red. Okay, so of course that works. You could try to print this out if you need to. I'm not going to do that right now. All right, so that is the discussion for variables. Now, there's a lot more to be said about variables, and especially about things like references and pointers. Okay, so the discussion will not end here. I just wanted to introduce the basics of working with variables so that we can go through the foundation of our language. And then later on in a more advanced part of our course, we will talk about what references are, what pointers are, how we can work with those, and so on and so forth. Okay, but that is a more advanced topic for when we have a bit more knowledge of Rust.